Good morning. Y'all are excited? You're on the roller coaster? You came here because we're very excited because so much is going on. We're on this crazy ride together. I don't think we're on the ride yet. So that's the purpose of my talk. It's like kind of explain to you. It's like, oh my gosh, what are we going to do? My name is Marco. I'm not a fancy product leader like Poppy. He'll be on later. He's my old boss. I'm not a slick marketing person. You're going to figure that out from my slides really quick. I'm a product manager. I'm here in the Bay Area. I went to the local college. I graduated in cognitive science, which is a lot of fun. I don't do linear algebra. I'm not going to make you guys do linear algebra today. We have people who can do that. I did product management for a long time. I've worked at HashiCorp with Poppy at Pivotal and Yahoo and Walmart. I was a data center guy at Walmart. I racked and stacked servers. And so when I wanted to figure out what we wanted to talk about, I was like, when am I going to talk with a bunch of infrastructure people? I was like, I don't understand how a lot of this stuff works. Everything is changing really, really fast. And every time I try to do research, everybody wants to tell me about how accurate their models are. But I don't really want to dig into that. I want to know how many servers are we going to have to buy? How much memory are we going to have to provision? How is this actually going to work? If I roll something out, like I'm a Walmart guy, I'm a Yahoo guy. If our web pages get slow, that's a disaster. How am I going to avoid those things? Nobody wants to talk about that. So the purpose of the talk today is I spent all night doing research, answering my own questions, because I kind of feel like maybe a bunch of you have these questions too. 2025 is over. What? The whole year went by, right? So let's talk a little bit about what changed over this year because it impacts everything that a lot of us do. And then super briefly, because it's very important and near to my heart, I've worked on a bunch of open source projects. I've worked on Hadoop, I've worked on Cloud Foundry, and now, through absolutely no intention of my own, I'm the product director for PyTorch at AMD, which I never looked for, but is absolutely my dream job. So let's talk about that super briefly. AMD and other companies are out there selling hardware. I've worked for hardware companies for a few years now. It's a little bit different than software. But we mentioned, you heard earlier, right? We're not going to talk about developers. I'm not going to make you learn Python. Well, maybe you. You look like a Python guy. Okay. You can see me afterwards and I will apologize. Okay, so we do everything open source. We do everything where the developer starts. We don't expect you to come to AMD and learn to be an AMD developer. We do have a session later on in case you want to come to learn how to be an AMD developer. We'll talk you through that. But the point is to meet people where they are, to be as quick to production and as quick to prototype as possible, and to give you the kind of community support that you expect without paying for it, because a lot of what we've done and a lot of what works in our industry is open source software. I'll come back to this at the end of the talk. But what I wanted to talk about this week, today, this year, is these two slides. And I will tell you, I worked embarrassingly hard because I don't remember how to make graphs in Excel anymore. So these took me a lot. I would like you to appreciate them. They're very pretty. This is as good as I get in terms of graphics. So notice that everything is up and to the right, right? Just like our finances, everything is up and to the right. These are the best that ChatGPT numbers could give me. If you come out of this and you say, I saw that Marco gave an incorrect number and I felt like his talk wasn't well researched, this is a keynote, guys. I'm here because I'm excited and I want to share my excitement with you. If the number is wrong, you can correct me afterwards. I'd love to talk with you. Okay, so we're going to go through two technology areas. And I just want to highlight these things because I think it'll give you an idea of why I'm so excited about the trend and where we're going. First, we're going to talk about reinforcement learning. And everybody remember this moment? Huh? Yeah? Hey, ChatGPT this morning, I did 3 push-ups and I brushed my teeth. Marco, you are amazing. Most people die if they were going to do 3 push-ups in a day and you brushed your teeth afterwards. This really happened. Like you could get this out of the system. And that was when most of the world discovered what the DeepSeek folks had already told us in January, which is reinforcement learning is the way we're going to do things from now on. It's like, okay, well, I thought I know how LLMs work, but how does reinforcement learning work? Well, it turns out it uses a lot of compute. And so we're going to just spend a few minutes talking about what reinforcement learning does, because I think a lot of us think like we understand, but every time we go to YouTube and we look at like all the videos and discussions about how does LLMs work, all this stuff. What we learn is, how they're good at predicting the next word. But what does that mean when you're training? So reinforcement learning is when, as you're training a model, you are grading itself based on human feedback. And so what ChatGPT and the world all learned at the same time is when the chatbot is flattering to you, you tend to hit the thumbs up button more, right? And eventually it'll do that. But what you may not know is on the two left-hand sides, these are the way that we traditionally have done training. We've done supervised fine-tuning. We've done even maybe some little work with reward models. But I don't know what it is, but like last week in AI never explained this to me. I don't know if you guys listen to these podcasts. When you're doing reinforcement learning, you have to run 4 models in memory at the same time because the way reinforcement learning works is as it's talking to itself, it grades its own work. Where does that come from? Well, there's not a human being with a clicker, yes, no, yes, no, yes, no. When you train a thing, it's called what is it called? The policy model. That's the most technical term I'm going to use today is you train the policy model, it talks to the reference model, it talks to the reward model, and eventually it talks to the value model, which is otherwise known as a critic, which I think is great. No, that's not a good answer. That's a lot of RAM. So that's the most important thing for the first takeaway, for the first part of the talk that I'd like you to take away is, as we are approaching more and more sophisticated models, as we're approaching more and more believable, useful, utilitarian chatbots, it takes resources. I know that's a surprise, but for me, the thing that I really wanted to explain to you on this slide is, how does this work? People keep talking about it, but this is a really good example. Now, I don't want to take away, please don't read this diagram. I don't want to take away from the work that the DeepSeek did. Like for every paper I read while doing this research journey, half of them were from DeepSeek. Those people are amazing. And they definitely did something that is better than PPO in terms of memory usage. It's called GRPO. And if you want to go study that, it basically shows how, let's point over here because you guys are on the right-hand side, my right-hand side. They don't need this model. It's like, okay, we don't need the value model. So they did save RAM. They didn't change the world, but they're very efficient. And I'm really impressed with what they're doing. So, my friends, my call out to them, but I just wanted to read this quote to you really quickly. It seems that the improvement it seems that the improvement is attributed to boosting the correct response from top K rather than the enhancement of fundamental, skip slide. Okay, last part on training, and then we're gonna get to some more fun stuff. I just wanted to briefly point out, there is some talk, people think about this, there's some pressure that says models are getting too big. They will hit a wall, they will eventually get to the point where they're having diminishing returns. Remember the 2 slides in the beginning? I don't see that to be the case, right? We just saw 2 frontier models come out there trained on 1 trillion parameters. That's a lot of zeros. I know that because when I was doing the stupid Excel chart earlier, I had to type in lots of zeros, and that was a waste of my time. So just briefly, this is a paper from Google Brain that shows how models reduce errors. The larger the model, it's reducing the errors in chain of thought models. What is chain of thought? Chain of thought is a form of reasoning model. So this is the thing that you guys are hearing a lot about. Oh, well, now we have a reasoning model, so we're going to AGI. I don't remember what AGI is, but I spell it out later in a slide so that we can all remember it together. And then also, when DeepSeek came out, do you all remember we started talking about Jevons paradox? Jevons paradox? That is not an investment strategy. That is a law about computing. And you know what it says? It says the more computing, just like the longer your meeting is, you will find stuff to use it for. And I feel like that's what's happening. I know that we were worried that once upon a time, and I was there in the internet, we laid all this dark fiber, and we were very excited about that, and then all the companies laid all the dark fiber, went out of business. Where do you think that fiber is now? It's all in use. So when people are saying, oh, scary, we're gonna hit a ceiling, I'm not seeing that. Let me see if I can convince you too. How many of you think you know how LLMs work? I bet you think it works like this, right? The LLM ploddly goes through and tries to figure out the most basic thing. That is not how LLMs have worked for a year now. Instead, they talk to themselves. And I think it's really important. And by the way, this slide comes from the folks here in San Francisco at the Allen Institute for AI. They make the Olmo models, which you might want to look up if this is something that you're interested in, this is your field. Everything they do is 100% open source. Turns out there's different shades of gray when it comes to open source. There's models that are just the open weights. There's models that talk about and publish papers about they do everything they do. It almost completely reproducible. So if you wanted, you can go do this too. And I think that's pretty cool. So I thought I'd share that with you. But the important thing is, you see that reflection trigger down at the bottom where it says wait, and then look in the upper right. I think I got it wrong. This is what we do too, right? If you guys like reading fast brain, slow brain, Daniel Kahneman type stuff, when we spit out an answer, we often spit out the easiest, most obvious answer. In reasoning models, we've taught models to do this themselves. I think you guys know this part, right? It's worthwhile to refresh though, because I want you to think about what that means. So we're hardware people. How many of us think about teraflops? Only 3 of us, okay. A little higher up. How many of us think about time to first token? Okay, there we go, a little more about that. And how about tokens per second? All right, there we go. What happens when your model starts talking to itself? Your tokens per second just went down by an order of magnitude, a factor of 10. This is really important. Average output length has increased by 5 times every year for the time that we've been doing LLMs. And that's what this model shows. I'm sorry, this diagram shows. I talk about models too much. It is true. So come back to reality. Like this is a little bit of hyperbole. This is where we're going, but there is research on token budgets and things like that. But this is the same way that we manage our budget. We're gonna buy the things that we're gonna buy, right? But we're gonna try and spend as little money because Black Friday is coming up. I will wait. That's what a token budget is. It's not a miracle. Okay, last technical slide. I put this one at the last minute. So do you remember at the beginning, I put a chart on the right for you really deep readers? You're like, Marco, you haven't talked about context length. You showed a chart that shows that context length increases over time. I found this amazing picture by artificial analysis of like, I don't know, 2 this morning. And so I put it in, and this is really, really worthwhile to point out. It shows the difference between how many tokens are generated by the answer. And I think you can best see that in the DeepSeek column in this, in the contrast of this screen, the DeepSeek or the Grok column. How many tokens are generated in order to reason versus how many tokens actually are delivered to the user. This is happening in hardware, right? This is happening behind the scenes. So I wanted you to understand and feel the same way that I was worried. Like, I don't understand what the impact of all this new technology is. I don't know what's happening. And more importantly, I don't understand what's coming next, right? So come back to my roller coaster. We are still going up. I don't know when the ride actually starts, right? Eventually we'll cross the chasm. Eventually we'll be old news like search engines. But here's a picture from DeepMind about the different ways that they are shifting the ratio from training time to inference time, which as a hardware person is terrifying because training is something that I can bound, I can manage, I can deal with. But when the users are using it and I need to get a response on an iPhone, right, they're less patient than they are behind a browser. How am I going to do that when we're trying to deliver this over 5G? So there's definitely a lot of research in how to do this, and I wanted you to be excited about that. I also wanted you to think, what sort of hardware are we working on? And you can see my amazing skills here, and you now know that I'm an authentic product manager and not a marketing person. But there is one company out there that is genuinely focused on competing, works in the open source, and I have to put in, I feel like it's worth noting, has more high bandwidth memory than the local competition down 101 from us. So super briefly, just to close, please join us later on. We have a couple of different talks. Ted and Ida and Godsi are here. So we'd love to see you later on. I will be available. I'll be here all afternoon. And thank you so much.